Martian Moons Exploration, MMX. Martian Moons Exploration, MMX, is a robotic space probe set for launch in 2026 to bring back the first samples from Mars' largest moon Phobos. Developed by the Japan Aerospace Exploration Agency, JAXA, and announced on June 9, 2015, MMX will land and collect samples from Phobos once or twice, along with conducting Deimos flyby observations and monitoring Mars's climate. The mission aims to provide key information to help determine whether the Martian moons are captured asteroids or the result of a larger body hitting Mars. JAXA and other Japanese government officials officially approved the MMX project to proceed into development on February 19, 2020. The probe arrived at Japan's Tanegashima Space Center, TNSC, on March 31, 2026, and it is expected to launch towards Mars in October 20, 2026 during the year's launch window. Overview. The spacecraft will enter orbit around Mars before transferring to Phobos, where it will land once or twice and collect regolith samples using a pneumatic sampling system. The mission is designed to return at least 10 grams, 0.35 ounces, of material from the Moon's surface. After departing Phobos, the spacecraft will conduct several flybys of Deimos before releasing a return capsule for Earth, with sample return planned for 2031. The spacecraft has a total launch mass of approximately 4,000 kilograms, 8,800 pounds, including about 1,900 kilograms, 4,200 pounds, of propellant. The spacecraft consists of three major elements: a 1,800 kilogram, 4,000 pound, propulsion module, a 150 kilogram, 330 pound, exploration module, and a 1,050 kilogram, 2,310 pound, return module. Because Phobos and Deimos have insufficient mass to support conventional satellite orbits, MMX will operate in quasi-satellite orbits, QSOs, a class of trajectories that can remain stable for extended periods while staying in close proximity to the moons. The mission is led by Yasuhiro Kawakatsu. International collaboration. MMX is led by JAXA, with participation from the National Aeronautics and Space Administration, France's NIS, French,
Centre National d'Études Spatiales.
Literal translation, National Center for Space Studies, Germany's, DLR, German,
Deutsches Zentrum für Luft- und Raumfahrt eingetragener Verein,
and the European Space Agency, ESA, who are providing scientific instruments. NASA will contribute a neutron and gamma-ray spectrometer, GRS, called MEGANE, an acronym for Mars Moon Exploration with Gamma Rays and Neutrons, which also means eyeglasses in Japanese. NIS will provide the near-infrared spectrometer, NIRS 4 macromega. NIS is also contributing expertise in flight dynamics to plan the mission's orbiting and landing maneuvers. Development and testing of key components, including the sampler, is ongoing. As of December 2023, MMX is scheduled to be launched in 2026, and will return to Earth 5 years later in 2031. ESA will provide deep space communication equipment, a transponder and power amplifier, and will provide ground station support from the European Space Tracking (ESTRAC) network. The sample return capsule will land in Australia. Spacecraft instruments. MMX will have 7 scientific instruments. Tengu, telescopic nadir imager for geomorphology, a narrow-field camera for detailed terrain study. Oroki, optical radiometer composed of chromatic imagers, a wide-field visible light camera. LiDAR, light detection and ranging, uses a laser to reflect light from the Moon's surface, to study surface altitude and albedo. MIRS, MMX infrared spectrometer, a near-infrared observation device for characterizing the minerals that make up the moons of Mars. Developed in partnership with NIS, France. MEGANE, MEGANE means, eyeglasses, in Japanese. Mars Moon Exploration with Gamma Rays and Neutrons, a gamma-ray and neutron spectrometer developed by NASA, Johns Hopkins Applied Physics Laboratory LLC, abbreviated as Applied Physics Laboratory or APL, and Lawrence Livermore National Laboratory, LLNL. CMDM, Circa-Martian Dust Monitor, a dust-counting device for characterizing the environment around the Martian moons. MSA, Mass Spectrum Analyzer, an instrument to study the ion environment around Mars. JAXA will partner with the Japan Broadcasting Corporation, Japanese,
日本放送協会
Hepburn, Nippon Hoso Kyokai, also known by its romanized initialism NHK, to develop the Super High Vision camera, which combines a 4K and 8K camera, making it the first time that Mars will be imaged in 8K resolution. Images will be regularly transmitted back to Earth with flight data, in order to recreate MMX exploration around Mars and its moons. The original image data will be stored in a recording device in MMX's return capsule and brought back to Earth as part of the sample return portion of the mission. The Gravity Gradiometer, GGM, Laser-Induced Breakdown Spectroscope, LIBS, Mission Survival Module, MSM, were proposed as additional instruments. ʻdaɪməs rover. Following a study by the French NIS Space Agency, it was decided that the spacecraft will deliver a small rover provided by NIS and the German Aerospace Center, DLR. ʻdaɪməs is a rover weighing less than 30 kilograms, 66 pounds. The instruments are 2 navigation cameras, NavCams, 2 cameras, wheelcams, that will observe the interactions of the back and front wheels with the regolith, a Raman spectrometer for MMX, RAX, and a miniaturized radiometer, mini-RAD. Its objectives are to touch the surface of Phobos, to check the behavior of the surface under mechanical actions and to relay this information to Earth. It must also demonstrate that it is possible to use wheeled locomotion on a body with such low gravity. Finally, it will take measurements in situ, observing the ground of Phobos at a resolution of 100 micrometers, and moving around on it. Sampling. MMX's sampler is equipped with 2 sampling methods, the coring sampler, CSMP, to gain regolith at depths deeper than 2 centimeters, 0.787 inches, from the Phobos surface, and the pneumatic sampler, PSMP, for samples from the Phobos surface. The robotic arm will collect regolith from the ground by shooting the CSMP mechanism. The CSMP mechanism is designed to rapidly perform subsurface sampling to collect over 10 grams, 0.35 ounces, of the regolith. It is equipped with an ejecting actuator that uses a special shape memory alloy, SCSMA. PSMP is installed close to the footpad of the landing leg, and uses an air gun to puff pressurized gas, pushing about 10 grams, 0.35 ounces, of soil into the sample container. Both CSMP and PSMP can collect samples quickly because the entire sampling procedure is scheduled to be performed in only 2.5 hours. After taking a sample, the robotic arm will transfer both CSMP and PSMP canisters to the sample return capsule. The spacecraft will then make several flybys of the smaller moon Deimos before carrying the sample return capsule back to Earth, arriving in 2031.